So example 4 is an example of continuous compounding. Okay, we're going to look at continuous compounding. But before we go and do that example, we need to first of all introduce what continuous compounding is. So, like I said in the last video, we looked at compounding more and more frequently, annually, semi-annually, quarterly, monthly, daily. And it seemed like we were making more money every time we compound more frequently. So what happens if we compound even more frequently than that? Every hour, every minute, every second, every millisecond. Can we do that? Or is it worth it? Is it even worth it? So let's look at that. Let's look at that now. So let's consider the compound interest formula. All right, that's just the accumulated amount is equal to the principal times 1 plus the nominal interest rate over the number of conversion periods per year times MT, right? The number of conversion periods per year times the number of years. Okay, that's our formula. Now we're going to do a little bit of sneaky math here. Now, I'm not expecting you to be able to do this math. I just want to I want to justify the formula I'm going to give you. All right. Like I said, I don't want to just throw formulas at you. I want to at least give you a chance to understand where the math is coming from. So what I'm going to do is a sneaky little substitution of variables. Okay. I'm going to call u, I'm going to call the m over r, I'm going to call that u. Okay. So the m is equal to ru. Okay. So I'm introducing a new variable u. I know it seems kind of weird, but and why would you think to do that? Mathematicians are very creative people, so you know we're gonna do this little substitution. So if I make that substitution, then anything wherever I see r and m, I want to do something in terms of u. All right, so here I have r over m, right? In my formula, I have r over m, but I've defined u to be m over r, the reciprocal, right? The reciprocal of that. So if u is m over r, then r over m is just 1 over u, okay? And then, like I said here, m is equal to ru. So this is going to be, I'm going to actually write it as u r t, okay? Here's that ru, same as rur. So I'm just substituting m. I'm replacing m with ru, but I'm going to write ur. Okay. All right. So now I'm going to rewrite this again. And what I'm going to do is, actually, I'm going to back up a little bit. I'm going to make a big square brackets here. And I'm going to write 1 plus 1 over u to the u, and then all of that to the rt. Okay, these are all equivalent things. I'm just using a little algebra to rearrange these equations. And what I'm really interested is this thing right here. What's happening to this thing right here? Because this is it's a very important this is a very important little value here. This 1 plus 1 over u to the u power is something when we take the limit as u goes to infinity, right? As it gets larger and larger. Okay, so we're getting into a little calculus here, but if we make u larger and larger and larger, it approaches a certain value. And you can see in this little table, they've substituted a variety of u values. Okay, 10, 100, 1,000, 10,000, 100,000, a million. And you can see it's approaching, you can see these last two values here are pretty much the same. It's approaching this number. It's an irrational number that's a lot like pi, right? It's an irrational number that goes on, that the decimal values go on and on forever without repeating, just like pi. And it has its own little special notation called E. It's called Euler's number. Okay, so E is Euler's number, and the value is 2.7182 something something something. It goes on and on and on, just like pi does. But it's its own little special number. It's just as special as pi. So it should have its own day, right? We should have E day as well as pi day. But that would have to be on February 7th or something. All right. So that's this number E. So if I then substitute, I'm going to take this, I'm taking, um, I'm going to let this u value get larger and larger. We know that that now approaches the value e, and so we end up with the formula for continuously compounded interest. It's just a is equal to p e to the rt. Nice little simple formula. Okay, and again, our variables are defined in the same way as before. So A is the accumulated amount, P is the principal, R is the nominal interest rate, and T is the time in years. Okay, nice little formula, easy to remember too. Pert, it's the Pert formula. All right, and E, so remember E is Euler's number, and that's on your calculator. If you should have, I'm assuming that you all have a scientific calculator or something that has E on it. Or you can type in the value 2.7. You can just like pi is approximated with 3.14. You could type in 2.71828 if you want to. All right, if you don't have E on your calculator, you'll have to have that in your notes what E is. But I think a lot of calculators that have an E to the X button, and it'll just then, you calculate the E to some exponent. All right, so let's take a look at example 4 now. We want to find the accumulated amount after 6 years if $1,000 is invested at 4% per year. Okay, so it's $1,000 at 4%, just like the other one, only now our time is 6 years instead of 3 years, as like it was in the other example. All right, so the first scenario we're looking at is if it's compounded daily. Okay, so in this first part, we're just going to use the compound interest formula, $1,000. So I should write that down. P is equal to 1,000. R is equal to 0.04. And in this case, our M is 365. M equals 365. Okay, so we have 1,000 times 1 plus the nominal interest rate divided by 365. And then we need the number of conversion periods over that 6-year period. So we need to take 6 times 365. Okay, we take to that power. The whole thing in parentheses, to that power. All right, so this is something I can put in my calculator, and I'll end up with $1,271.23. Okay. Now let's compare that to the same thing, only compounded continuously. So we're just going to use our compound interest, our continuously compounded interest formula, PERT, right? So the accumulated amount is equal to the principal, P, E to the R, 0.04, T times 6. Okay? So that's also something I can put into my calculator, and I'll get $1,271.25. So it's, at least compared to compounding daily, it's only going to earn you a couple more pennies. All right, well, that takes care of continuous compounding. And I'll meet you in the next video to talk about effective interest rate.